Hello again. We are doing the quadratic formula, which I think is absolutely fascinating. A lot of students don't like it because they say, "Oh, it's so long. I can't, do this problem because it takes too much to memorize." I'm going to give you a tip that my teacher told me when I was younger, when we first learned this. Some students complained that they didn't want to memorize it, and she said, "Do your homework." And I said, "Oh, yeah, but we can't memorize this." She said, "Okay, here's what you do. Write out the formula for every problem that you have to use the quadratic formula with." And people complained. I just sat there. I didn't say anything. And then she looked at the students who were complaining and she said, "You know what? Stop being lazy. Write out the formula for every problem, and I promise it'll get into your memory. If you don't, then you're going to forget it." I was laughing, actually. I thought that was quite funny in the classroom at the time. I don't think those students found it funny. But actually, it goes without saying. If you want to memorize this, start writing it down when you do a problem. And then it starts to become second nature. Because if you don't, you're not going to memorize it, then you say, there's no way I can memorize it. Did you actually extract the effort to try to memorize this formula when you're working with quadratic functions? And if the answer is no, then put some effort forth. And if the answer is not, then keep working. It's part of that teacher in me who says, just do what you're supposed to do. So the quadratic formula is trying to find solutions for a quadratic equation. You're trying to find where the x-intercepts are on a graph. And the formula is x equals, and by the way, this is derived from a quadratic equation into this using completing the square. Quite cool. X equals the opposite of b. Now some people say negative b, but I say opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. There's actually a song on YouTube that uses a Little John song, and I really like it. It's actually quite cool to show. It's a nice little rhythm. You'd have to look it up yourself. But I actually use it in my classroom, so I think it's pretty cool. But I say the opposite of b instead of negative b, because if this were a negative 5, students would still put in a negative 5. But if I say the opposite, then students know it's the opposite. If this was a negative, they put in a positive. If it's a positive, they put in a negative. Now, in order to do it, you got to get it in standard form from highest degree to lowest degree. So what you want to do is get it set equal to 0. Well, it's not set equal to 0 right now. (3x squared plus 5x subtract 8 equals 0). Now it's in standard form. Now it's a quadratic equation. Now it's set equal to 0. Now we're going to notate what our a, b, and our c are. Our a is the number in front of the x squared, which is 3. Our b is the number in front of the x, which is 5. And our c is the number by itself, which is negative 8. I do have a lot of students who just put this into their calculator because they don't want to do the arithmetic, or maybe they don't feel confident. I'm not really sure. And I guess my heart goes out if the confidence isn't there. But if they're just doing that because they don't want to do it, that annoys me. So work on that, if that's you. But if you're just working on your math skills and trying the best, then I understand, then I can sympathize. So anyways, back to what I was going to say. X equals the opposite of b. B is 5, so the opposite of b is negative 5. Plus or minus the square root of, I'm going to stop there, b squared. Now b squared, b is 5. B squared is 5 times 5, which is 25. I'm going to go ahead and write that down, and I'm going to show you a little trick. I don't care if this number is positive or negative for this part. If it's negative 5, it's negative 5 times negative 5, which is 25. And if it's 5, it's 5 times 5, which is 25. So this number right here will always be positive no matter what. No matter what, this number will always be positive when you square it. If it was a negative, it turns positive. If it was positive, it turns positive. This one is just the opposite. Subtract 4. Now I want to put the other ones in parentheses. Times 3 times c, which is negative 8, all over 2 divided by 3. Students use shortcuts here and then they get the answer wrong and they can't figure out why. You got to do it systematically, step by step. Here's a little tip. If there's one negative here, when you're multiplying these 3 numbers, the answer is negative. If there's 2 negatives, the answer is positive, and if there's 3 negatives, the answer is negative. Rewind that back if you need to hear it. So negative 4 times a negative is positive 32. 32 times 3, or you could just go right in order. 32 times 3 is 96. Yeah, it's got it. over 2 times 3, which is 6. X equals the opposite of b, negative 5, in this case, plus or minus. 25 plus 96, somebody out there help me really quickly, 106, 116, 121. The square root of 121 over 6. Now this works out perfectly. If it didn't, you'd have to, use factor trees. This one happens to be very nice though. Some people say, can we use decimals? I use decimals on a word problem, but I don't use decimals if it's not a word problem. Because in a word problem you can explain it in decimals. But on a regular problem, if they say keep it in perfect form, you gotta keep it in perfect form. X equals negative 5 plus or minus, the square root of 121 is 11. And it's all over 6. Now here's the other mistake that students generally make when I'm grading this part. And I always emphasize it, but sometimes it just doesn't ring out as well as I want it to. This is negative 5 plus 11. And students do all these steps right, then they get this one wrong, because they go ahead and they put this in their calculator. If you want to put it in your calculator, fine, but make sure you do it right. You put parentheses around the numerator. And the other one is negative 5 subtract 11 over 6. And negative 5 plus 11 is 6. 6 over 6 is 1. And negative 5 minus 11 is negative 16. Negative 16 divided by 6 is negative 8/3. And I would rather leave that as a fraction than rather put that as a decimal. But for the purpose of plotting, let me just show you what's going on. So I'm going to go ahead and erase all this work, but I'm going to leave those two answers there. And if I were to draw a graph really quickly of this without knowing anything about it, these basically mean my x-intercepts. I didn't even circle it. Pardon. It's 3x squared plus 5x subtract 8, so it's a positive, so it's going up. And I know my x-intercepts occur at 1, and then negative 8 over 3 is negative 2.66 repeated. So it's like right there, goes up. Graph looks something like that. That's without graphing. That's without using a table. That's without vertex form, completing the square. Using tables, I probably already said. But that's just like a quick picture. And that's what we used to do in school too. Like we used to have to figure out what it was. I don't know what the lowest point is because I have to figure out what the vertex is. And in order to figure out the vertex, I'd make a, negative 5 over 2 times 3, which is 5/6. Negative 5/6, negative 0.8. I'm not going to do that. That's not what I'm trying to do on this particular problem. All I'm trying to do is just use a quadratic formula. With that said, I think that's a pretty good introduction into it. But for right now, have a great day.